Okay, greetings, guys. This is a walkthrough of the Unit 4 practice test. This is the second page. It's going to start with another solving one. So I'm looking at this one, and I can factor this. X over x plus 3 minus 3 over x equals 9 over x times x plus 3. So I look my common denominators. This has an x plus 3. This doesn't. So I'm going to multiply by x plus 3, top and bottom. Cool. This has an x plus 3, so that's good. This has x, x. This one doesn't, so multiply by x, top and bottom. Now the denominators are all the same. So think about restrictions. X can't be equal to negative 3 because negative 3 plus 3 equals 0, or 0 because can't be 0 there. So that's all gone now. And I've got x squared minus 3 times x is 3x. Negative 3 times 3 is a negative 9 equals 9. So once I've got the common denominators, I just distribute through. Be careful of that negative. Really easy thing to miss. Negative 3 times x, negative 3 times 3. Cool. Okay. I'm going to subtract 9 from each side, and I get x squared minus 3x minus 18 equals 0. I can factor that. That factors into x minus 6 and x plus 3 because factors of 18 that subtract to make 3 are negative 6 and 3. So x is equal to 6 because 6 minus 6 makes 0, and negative 3 because negative 3 plus 3 equals 0. Okay, but last step, when I compare this to my restriction, see this? So x can't be negative 3. That's a restriction, so my only solution is x equals 6. If I had to cancel out both of them, it would have been a no solutions case. Okay. Number 10. Every year, junior and senior classes, at Hillcrest High School, build a house for the community. It takes the senior class 24 days to complete the house, 18 days if they work with the juniors. Oh, this is a work problem. How long would it take them to complete the house if they worked alone? Okay, remember the model for this. You will see a work problem. You're going to have 1 over the time for the first person alone. So the senior class to complete it alone. So 24 plus the junior class takes 1 8. Oh, wait. Oh, how long will it take the junior class to complete it if they work alone? So I don't know that. That's x. And this equals 1 over 18 because that's the together. So it's 1 over alone plus 1 over alone plus equals 1 over together. Now, a variation of this, guys, anyway, I'm not going to go in there because you don't need to know that right now. Okay, now I just got to solve this. Well, let me show you something. See how these are both numbers? I can actually just subtract 1 over 24 from both of these. And I end up with 1 over x equals 1 over 18 minus 1 over 24. That's just that's a fraction problem. I'm just getting up because I don't want to get my calculator because it's way over here. I don't want to do that in my head, so I'm not going to. I'm just going to go in my calculator and hit 1 over 18 minus 1 over 24. This is the first time I've touched my calculator today. And I get 1 over 72. So 1 over x equals 1 over 72. Cool. Now I've got a proportion. I can go 72 times 1, that's 72. 1 times x, that's x. So x equals 72. So it would take the junior class 72 days because they're slow. Well, slower than the seniors, at least at this school. Cool. Okay, solve each inequality algebraically. Okay, when you're solving an inequality algebraically, remember, you're going to make a number line, negative infinity to infinity, and I'm going to find all of the zeros and undefineds for this. So if I look at this, I get x plus 7, x squared minus 25, that's a difference of squares. So x plus 5, x minus 5, and for my undefines, I get x cannot equal -5 or +5. Okay? And when I'm doing equals 0, well, really, this denominator just multiplies by 0 and just is gone. And so I get x equals -7 as my 0. So I just have to find the zeros of the numerator to find this value. So now I've got three numbers, -7, -5, and 5. So -7, -5, and 5. And it's hollow dots at all of these because it's not equal to. Cool. Remember, if it's equal to like this, it's solid dots. Not equal to, it's hollow. Now I just need to test every single one of these things. I'm going to find 0. If I put 0 in here, I get 7 over -25. That's a negative number. So there. So x equals 0. It ends up being 7 over -25. What about x equals 5 to infinity? Let's put a 10 in there. X equals 10. 10 plus 7 is 17. 10 squared is 100. 100 minus 25 is 75. Well, that's positive. -7 and -5. Let's put in like a -6. X equals -6. -6 plus 7 is 1. -6 squared is 36, and 36 minus 25 is 11. So positive over positive, that's going to make a positive. -7 to negative infinity, let's put in -10. -10 plus 7 is -3. -10 squared is 100. 100 minus 25 is 75. -3 over 75 makes a negative. Now, I'm looking for where this is less than 0. Well, less than 0 means negative. So it's here and here. So it's just negative infinity to -7. I just go through the numbers I've already marked on there. Union. And these are all parentheses because nothing's equal. -5 to 5. Cool. Okay, so find the zeros, which you can always do by finding the zeros of the numerator. Find the undefined values, which you can do by finding the zeros of the denominator. Those are our, what I call my critical values. Sorry, I'm yawning. That's terrible. My critical values. And I graph those on the number line. That creates intervals, and I test them all for positive, negative, and I call it good. Now, x cubed plus x squared is greater than 12x. First thing, I want to set it equal to 0. So I get x cubed plus x squared minus 12x is greater than or equal to 0. I just subtracted 12x here and there. Okay, now I need to factor that thing. So I see an x in each one. That gives me x squared plus x minus 12. And I can factor that. X times x plus 4 times x minus 3 is greater than or equal to 0. Okay. Now, let's make my number line get ready. Negative infinity, infinity, and so my zeros. Here it's 0 because x equals 0, 0. Here it's -4 because -4 plus 4 makes 0, so -4. Here it's 3 because 3 minus 3 makes 0. So my zeros are -4, 0, and 3. And these are solid dots because it is or equal to here. Okay, I can't do 0 because it's one of the zeros, but I can do 1. If I put in 1 here, 1 cubed is 1, plus 1 squared is 1, and minus 12. -12 times 1 is -12. 1 minus 1 minus 12 is going to be a negative number. So 1's right here, that's going to be negative. Now, if you remember right, none of these zeros have multiplicities. So this is just going to alternate back and forth, negative, positive, negative, positive. So I could go here, negative, positive, and then negative, positive, negative, and fill that in because I understand the multiplicities. If not, test every interval. -4 to 0, how about -1? -1 cubed is -1 plus -1 squared. -1 squared is 1. So -1 plus 1. -12 times -1 is positive 12. Those cancel, and I get a positive. Negative infinity, -4. about negative 5? Negative 5 cubed is negative 125. Negative 5 squared is a positive 25. Negative 12 times negative 5 is a positive 60. And this ends up being a negative number. Negative, positive, negative, and this will be positive also. Now, I want to know where it's greater than. Greater than is positive. So here and here. So my answers are negative 4 to 0 with a bracket on each one. Union 3 with a bracket to infinity with a parenthesis. There's my answer. Okay, so on inequalities, you're going to find the zeros, set it equal to 0, find the zeros, and any undefines. Remember, the only one that has undefined, is fractions. Okay, and then put those values on a number line and set your intervals. Now, 13 and 14, I'm going to be honest with you. I'm not going to put those story problems on the test. So I think you can not worry about them, but I'm going to go through how to do them here. Okay? A packaging company has designed a new open-topped box with, well, story problems, I mean like this. I'm going to have a work problem like number 10, but not a problem like 13 or 14. The box is to be made with a open-top box with a volume at least 500 inches. So I'm thinking the volume of a box. Volume is equal to length times width times height, right? But it says the box is made from a piece of cardboard measuring 20 by 24 and cutting identical squares. So if I cut a square out from each side, it kind of looks like that. Cut, 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 cut. And then I fold up the sides. So see, the base of your box is right there. And this is what you don't know, your x. So this is x. So your box has dimensions of x for here, and that dimension is 24 minus 2x because it's 24 inches. Take away this x and that x, you cut it out, and you cut it out. And this dimension here is 20 minus 2x. Okay, so with at least 500. So the volume is the length, which is 24 minus 2x, times the height, which is 20 minus 2x, times the height, which is x, and that has to be greater than or equal to 500. Okay? Now, with this is something that would end up being graphed on decimals. And when you would graph it on decimals, it's going to look like that. And I want to know where it's great, if you set it equal to 0, that is, where it's greater than 0, which would be right there. Okay? Okay. 14 would be very similar, it's done the same way. And I know I didn't put a lot of explanation. I know I didn't finish that, but I'm not going to give you one like that on the test at all. So I don't want you to worry too much about it. Perimeter of a rectangle is 80 feet. Describe the possible lengths of the side if the area is not to exceed 375. Well, if the perimeter is 80 feet, that means if this is x and that's x, well, these two sides have to add up to be 40 because it's half of the 80. So this is 40 minus x, and this is 40 minus x. And the area is the length times the width. And that's not to exceed 375. Okay, if you were to graph that, set it equal to 0 and graph it, it's going to look like that. And your solutions are between those two numbers. Okay? So these would be done graphically with decimals. Now, let's look at 15. Which of the following is an asymptote? Circle 1. Well, let me think. Horizontal. The bottom is the higher degree, so that says horizontal is y equals 0. Because remember, if the top degree is more, doesn't have a horizontal. Bottom degree is more, it's going to be y equals 0. If they're the same, it will be the leading coefficient or the leading coefficient. What about this one? What's just an asymptote? 4, 2 is the degree, so the top is higher. which means it doesn't have a horizontal and might have slant. So there we go. Okay, which of the following is an asymptote? Cubed. Hey, the degree is the same. So it's going to be the leading coefficient, which is 3, or the leading coefficient here, which is 1. 3 over 1 is y equals 3. Okay, there's the second page. On to the third page and on to another video. That's it.